Hi, everyone. Just to introduce myself up here, I'm Felicity O'Kelly. I'm one of the investment principals at Climate Investment. Super excited to introduce this next panel on the climate impact of generative AI. I was trying to find a very pithy CO2 reduction amount or percentage, a bit like Hannah May did before, but unfortunately, everything I read disagreed with each other. I think the reason being is we are kind of building the plane as we're flying it with AI. I know AI is not new, but the applications to climate and decarbonization and the energy transition, we're still trying to figure out where those can be. So with that, I'm going to pass to Anil, who's going to introduce his panelists.
So the genesis of this panel began when we asked the question, what is the CO2 footprint and water footprint of one ChatGPT search? Is this the same as Google search? What about deep learning? What about different types of neural nets? And the questions went on and on and on. I scratched my head and I said, okay, we should have a panel on this. I'll welcome Helen Lin first, partner at One Ventures, who recently raised their fund 2 at $375 million. Awesome team. We've invested together in Ascend.
Yes.
And welcome, Helen. Second, we've got Andrew Perry, or Andy, I'll call you, who's the Director of Energy Transition and Environment at Faculty. Andy leads the faculty's Energy Transition and Environment business unit, which designs, builds, and deploys bespoke AI solutions for businesses across the sector. Faculty is Europe's leading applied AI firm with a 10-year history of developing AI-based solutions for clients. Welcome, Andy.
Thank you.
Third, we've got Kelly Chen, founding partner at NATO Innovation Fund, or NIF. Can I call that?
Yeah.
Okay. That recently launched a whopping $1 billion fund to invest in deep tech startups. Kelly used to be at our corner in Silicon Valley at DCVC before, and now she's a recent London resident. Can I say that?
Yeah,
Okay.
in transition.
In transition, okay. I'll start with a couple of quotes from the recent past. Training a single AI model can emit 626,000 pounds of CO2 equivalent, according to a 2019 study. This is old. Energy and policy considerations for deep learning and NLP is the paper, if you want to go read it. This figure is nearly 5 times the lifetime emissions of an average American car. Just let that sink in. Training GPT-3 in Microsoft's state-of-the-art US data center can directly evaporate 700,000 liters of clean, fresh water. But this information is apparently a secret. More critically, the global AI demand may be accountable for 4.2 to 6.6 billion cubic meters of water withdrawal in 2027, which is more than the total annual water withdrawal of 4 to 6 Denmark, or half of the UK. Let that sink in as well. So, that said, I'm going to ask the first question to our panelists. What is the climate impact of running data centers in general? And in specific, what role does AI, and specifically generative AI, play in potentially exacerbating climate problems or making it worse? Kelly?
Sure. So I think you just had the most quantitative data on the data center impacts on AI. And when I was looking at this, pre the new Gen AI phase in the last few years, data centers already accounted for over 1% of global emissions, let's call it 2020, 2021. So right now with generative AI and all of the needs that we'll have with larger models, more data, more compute, we're going to be looking at a lot of strain and a lot of needs and infrastructure in the next, let's call it 5-10 years. So this means a lot more land for data centers. It means a lot more energy usage, which we'll talk a bunch about. And then on the water side for critical cooling, as there's more compute, potentially higher temperature levels, and thus more need for innovative methods of cooling.
Andy?
So I want to talk specifically about the AI aspect of that. I think when we think about, so AI, obviously a term that's massively used now, there's two parts, I think, to the energy usage problem with AI. Like, part of it is the training of the models. Obviously, that adds a very intensive nature, but then there's also the usage of the models. Now, if you think about the training, I'll add another sort of quantified stat in. So there was a study done on Bloom's large language model. So Bloom's model is something like 175 billion parameters, which is, it sounds large, but ChatGPT or GPT-4 was 1.5 trillion parameters, so it's about 10 times as bigger. So Bloom's model took about 50 tons of carbon to train, so in terms of the energy usage. Now, obviously, that relates to like where it was trained and the carbon intensity of the grid, but it's about 50 tons, which is about 45 UK households over the course of a year. So that's a lot, but when you think about training a model, if training a model is a relatively one-off activity, and it's being done in the hundreds of times, then that's probably manageable. That amortizing that over the course of the lifetime of the model and the usage of the model, that doesn't seem unmanageable. However, the usage of the models is then a whole different thing. So, and that's where generative AI has really changed the game. So obviously in training it has, but in usage, we're now seeing these models be used at a macro scale across the world, hundreds of millions, billions of users. So ChatGPT was, I think, the quickest software to 100 million users of any software that's been released. So Bing, using an LLM as part of their search capability, that has a 4 to 5 times impact on the carbon intensity of search.
So maybe we'll double click right there
Yeah.
on the models, because I know that the number of parameters has increased, right? So like you said, it's gone up to 175 billion, is that right?
That was Blue, yeah, but 1.5 trillion is GPT-4.
Yes, right, sorry. And I heard somewhere that the next one is going to be some quadrillion. I don't even know what quadrillion is, actually. So what does that do?
Again,
to CO2?
if you're building tens of these models
proportional?
or hundreds, then I mean, we can go into those sort of management of the CO2 impacts. But I think if it's on a limited set, then there will be cases you can make to justify it. I think if you're starting to build hundreds of thousands of these models, like clearly you've got a huge issue. But I think, we'll come onto it probably later, but there are ways of mitigating it. There's responsibilities that we all need to take. But also, maybe what we can come back to is the fact that these are tools. And so it's actually all of our responsibility about how we use tools and how we want to allocate our resources. And what's interesting with things like AI models is that it's a very invisible impact. So you don't think of it as like using resources when you type your question into the chatbot, right? But like you are using resources, but you're using a very tiny, minuscule amount of resource, but done billions of times, then that's going to be a very large amount of resource. So the people like us who build these models have a big responsibility, absolutely. But there's a kind of a much broader societal responsibility about how we view this and how we want to use it.
Let's hold that thought, because I'm going to come back to it later. But Kelly, we talked about training, but what about inference? Do you think there's going to be more carbon footprint on inference, and then there's more on use? Like, is this just simply more and more and more? Is it going to get worse with adoption?
Yes, in short. So on the energy side, on the climate side, there's going to be more and more needs on there. And then how that actually implements in terms of final output, in terms of emissions, in terms of total energy usage, I think there's a number of solutions, and really interesting, both from startups and large corporates, solutions to making sure that the impact isn't going like this in terms of negative impacts. It's more so a much slower scaling, and hopefully one day something that will tip down.
Helen, I'm going to get back to you on the first question, which is
climate impact in general.
Correct.
Sure. So fully agree with everything that's been said so far. Maybe just another couple interesting takes on some of that, where if you imagine for a moment that Google started to switch fully everything from just regular search to something more like ChatGPT, they have 9 billion searches per day. right? So if you were to convert 9 billion regular searches per day to 9 billion chatbot interactions per day, then Google would suddenly need the same amount of power as the country of Ireland, which is kind of, like you said earlier, let that sink in, you know? And so, I mean, I think like it's not just like, oh, is the answer yes? It's like yes, and in an extreme. And what's also interesting is I agree that there's mitigants and there's solutions both on the hardware and the software side. Ironically, on the software side, when you start reading through some of this, one of the software solutions to the energy intensity of data centers is AI, which is like mildly ironic, you know, to like optimize like when's the best time to turn on your HVAC when there's like peak processing and and you're kind of like, wait, but isn't AI kind of the problem to begin with? Anyway, but then on the hardware side, what's really interesting as well is you've seen there's been some Moore's law, right, with just increasing the efficiency of like data center hardware and better modern HVAC solutions, et cetera, et cetera. A lot of people are thinking and saying that we may have actually reached a little bit of threshold of saturation with how much improvement in energy efficiency we can achieve with these hardware solutions. And so if you look at the graph of like how much energy intensity has increased just with increasing internet usage and stuff like regular search, Google search, right? Then that's already been offset by some of these hardware improvements in efficiency. But if we've already hit that ceiling on efficiency now, or we're close to it, then there may actually be a cusp, right, of now like the net like energy consumption because we can't really offset it that much more.
When you say hardware, is it the cooling or is it the chips?
It's both.
Or okay, it's all of the hardware.
Yeah, I mean, you
combined.
know, I'm a climate VC, so like I tend to, anything I look at in data centers is generally geared towards like how do you reduce its climate impact. So we've looked at stuff where like new kinds of servers, like the actual server hardware that are more energy efficient. We've looked at novel forms of cooling. Obviously immersion cooling is starting to be a thing, but it's not easy because you can't just take a regular server and dunk it in like, you know, immersion liquid, like that's just gonna break everything. So, you know, you have to like engineer special kinds of like the way the chips are encased and everything. You have to like re-engineer the whole plumbing in your data center facility to be able to enable immersion cooling. You know, there's companies doing like 3D printing of like metal sinks, like metal heat sinks and stuff like that. So, I mean, it's nascent, right? And so, but there is stuff both on the data, the server hardware itself, the cooling systems like immersion, and also just traditional HVAC as well.
Are there any, just as a double click there, are there any language models that they themselves are energy efficient? Is there like a small language model? I don't know. I just feel like I'm totally ignorant here. Are there smaller sort of I've heard something like mini AI, or I can't remember the word, but the edge guys talk about this quite a lot. Are there models that are innately more energy efficient?
Yeah, so I mean, to the irony point, so it's an interesting one. So I think there's something about how AI is seen, and the thing I really want to stress is like AI is a tool. So think of it like a computer, right? So computers use a lot of resource. They can do amazing things, and they also create massive problems in terms of energy use, et cetera, right? AI is just the same. So it's all about how you use it and how you apply it and how you structure it. So to your point about, well, how do you manage like an AI model? Generative AI is different to traditional AI insofar as traditional AI is very narrowly focused. It's a very specific instance where you're trying to solve a particular problem by building an algorithm and a software around it. Generative AI is a general purpose model and therefore is trained on everything. Now, you guys will all know this by now. But that's a huge difference in then like what you're thinking about as you're building this thing. So a traditional AI model generally has a very low impact when it's built, because in the end, it's very narrowly constrained in the types of data you're putting in, the types of things that you're trying to get it to do, and therefore the processing power it requires to train. A generative AI model has like massive impact because you're literally applying it to anything it gets asked. It has no particular purpose. It has a generic purpose. Now, what that then means is if you're not resource constrained, then you'll keep adding data and parameters to this model to make it more and more powerful, and expanding then the sort of field of vision of what it can do. But yes, there are ways of managing this because a lot of that is quite ineffective depending on what you actually want to use something for. And what may well happen is that while for now it's like a bit of an arms race of like ever expansion to build more power, I'm pretty sure we're going to reach a point like in the not too distant future where we kind of reverse that and realize that having more narrowly constrained generic models, so generative AI models, will be more effective because we train them for specific purposes more. And by doing that, that will also narrow the resource requirement. Yeah. And so there are a couple of ways you can do that, generally within AI models. One is like being careful about what you're choosing in terms of your modeling approach. So different types of machine learning approach have different types of sort of processing output and requirements. But also something called quantizing, which is effectively managing where you need specific versus more high-level data and processing. So depending on your purpose, like you don't necessarily need like the whole world to go into your model. You can be much more choosy about like how you're setting it up and how you're running it, and that means you could be way more efficient. So yes, but these things are relatively unexplored at the moment with generative AI because it's just arms race. Yeah. Let's like whack as much as possible in here and like get more and more power into it.
Yeah, but I mean, one thing that the flip side of that is we're gonna have more robots, more cars. My phone has got ChatGPT on. This is gonna be everywhere. So even if we did all of that, I fear that this is gonna be still a massive energy sink in the end. And we have to figure out how to deal with that. Maybe that's a perfect segue for us to get to the next question, which is, what kinds of innovations are you seeing these days in both the next generation data centers 2.0, whatever you want to call that, or even generative AI to even solve some of the climate problems? Maybe I'll take everyone's take a little more positive take on this.
Yeah, that's a great question. And then this is a nod to your prior question in terms of can we use large language models, shrink it down? And I'd say there's a reason why in the last few years, when we think about deep learning and what's most investable in the deep learning field, it's largely been on the computer vision side because you can have very narrow use cases that you're training on. And before the explosion of LLMs recently, right, it's just in practice, when you don't have large models for language, the execution looks terrible and it's not usable commercially. So if you think about chatbots in 5 years ago, it's not something that people wanted to interface with. So on that front, we need this new iteration of how good it is. And then yes, we needed to start large, and now we can start slowly thinking about shrinking it down. And then in terms of Gen AI and potential good implications on climate, something that Kellen said, and she mentioned Google and examples of how AI could help on the data center side. So when Google, let's call it, this is pre-Gen ChatGPT era, Google has a ton of resources to be able to shrink down their data centers and energy efficiency. They've been working on it for a long time. DeepMind came in, and within not so long of a time, they reduced the energy usage and the emissions from Google's overall data centers globally by something like 40%. And that's using AI. So this is pre the new wave. So I'm excited to see what the implications are there.
Awesome. Andy?
So maybe to set up this like responsibility we have for how we use AI, right? So and there's no correlation between the amount of processing power and resource intensity and size of a model and the good that it does. These two things are completely separate. So you can get very narrow, small, like specifically targeted AI solutions or AI-driven solutions that can have huge impact on climate, on productivity, on various things, and we try and create them. And you can have massive resource-intensive general-purpose models that are used to perfect everyone's selfies on hundreds of billions of instances around the world, which has huge resource intensity but zero productive impact, right, for us. So there's just no link between the two things. So if you think about like positive impacts of where AI gets applied, I mean, I'll talk about some real examples that we're involved in. Energy transition, which is probably the biggest driver of us being able to combat climate change, is basically an optimization problem. So building renewables in itself is not difficult. We understand how to build wind farms and solar panels. We also understand how to build electric vehicles and how to make them pretty much cost competitive. And we know how to build heat pumps, not necessarily as cost competitive, but broadly the problems of electrifying demand and creating renewable generation are largely solved from a capital point of view. Our biggest issue is about how we make a system work that can connect these two things together at scale. And a lot of those problems are around networks and systems and flexibility and balancing supply and demand. And you guys, I'm sure, would all know this. AI is so perfectly suited to solving many of those problems. So like we're working with National Grid System Operator about like how do they forecast outages from renewables on their network, and then how do they make action like very quickly, because their own engineering models take a week to run. So we can do a machine learning model that gives you an 80-20 view like within minutes. We're working with them on voltage optimization because voltage gets messed around again by renewable impacts on the grid. We're working with Northern Power Grid, a distribution network operator, about how they forecast embedded generation and electric vehicle impact on their local network where they have no visibility. We're working with a small startup called Drift Energy that's producing electricity from wind through sailing boats into high wind areas, driving wind turbines underneath, the wave turbine, creating electricity and then electrolyzing that on board into hydrogen, which is stored in their hulls, which they bring back to port. An amazing business model. We've developed the routing optimization for that using AI. So how do you target your boat to the highest areas of wind in a strategic way? So there's like loads of different AI applications, and one that we haven't really explored properly yet, certainly as a system here, and I think globally, is how you really get renewables and flexibility to work well together in a co-developed way, largely because co-development rarely happens still. But solar and wind farms combined with battery storage and demand response, and how do you make these things interact, and how do you forecast their outputs and then play that into the market effectively and optimize, again, the price and revenue that you can receive. All of these things are like classic AI problems because they're basically about optimizing decisions using complex and varied data sets where you need to understand patterns and where traditional kind of logical sequence modeling just won't cut it. So there's loads of benefits, but unfortunately they don't correlate with like the massive resource intensity. And generative AI itself has maybe some applications, but in energy and climate, they're relatively limited. It's more like traditional AI that's probably more powerful.
Helen, any moonshots that you've seen recently? I know you guys fun moonshots. So
is that the reputation that we have now? Okay.
of course you do.
No, they're not moonshots because they're commercializable. Yeah, so like moonshots are not commercializable. But no, I think a lot of what you just said really resonated. I know we're talking about the opportunity space right now, so I don't want to sound like negative during our positive minute, but like, but as again, with the investor perspective and lens, I do think, on your responsibility point, we have a responsibility not to get overly excited about a new shiny technology just because it's new and shiny, and to, not to play our part to be pushing something that is resource intensive when it's not necessarily needed. Right, so like maybe your question about is there a mini generative AI is just it's regular AI, and like,
but even that is resource intensive.
Sure, I mean it's less so, right? But I think right now Gen AI is like the buzz, and so like there's so many of those interesting applications, right? Where we've invested in AI in the past has been regular non-generative AI, and I mean those are often in any industry or sector where you have a lot of experimental iteration. That can be very costly, right? Because it's you need the people, you're burning runway, and just like the more you have to try and fail and take time to do that, it's just like for a startup, it's death. And so whether you're in food tech or whether you're in green cement or and you're trying to find different mixes of ingredients and different processes of treatment to like get to an ultimate outcome of performance on a material or a product. Right, that trial and error that traditionally has just been done by a bunch of really smart scientists in a lab, but is trial and error at its core, right? It is what kills a lot of early stage companies. And so if you can accelerate that with even regular AI, and sure, if there's an incremental gain to be had with generative AI in that sense, I think that as like a kind of macro arc can be really accelerating and helpful for a lot of companies in our space. I think the question comes down to the incrementality of it. And then, I don't know, maybe we should start looking at like netting off, right? What is some kind of resource intensity penalty that you then attribute as an investor to this? And if you net that off against the incremental benefit of using Gen AI versus regular AI, does it still make sense? That's probably very hard to quantify, but I think maybe we should start trying to think and trend in that direction a little bit.
I think just building on that point, one of the things that doesn't exist yet is real transparency about energy usage of not just AI, but across compute and how it's used. So the starting point has to be like tracking and measurement becoming far more embedded in expectation. And then when we are creating any type of software or whether it's AI or not, like being able to categorize that and to quantify the impact from a resource point of view, and then to build it into decision making. You know, so to your point, like actually build that as a parameter in, because right now it's just completely ignored.
Maybe Kelly, one question for you is, you mentioned vision as computer vision as one opportunity. What's beyond computer vision, just as an opportunity in that generative AI kind of space? Have you seen interesting, climate/industrial opportunities that have a climate impact?
Oh man, beyond computer vision. I think
beyond vision, computer vision.
Right, and when I was mentioning computer vision, I was more so talking about in the last 5 years as we're looking in deep learning. That was a trend because in practice, what is viable from corporates, from the market was along those lines. I think the next phase in terms of if we're looking at more complex than standard AI, like generative AI, the biggest opportunities are certainly on the language side. And right now, we're already seeing it in terms of the number of companies that are coming out and building on top of this. So I would move away from being a computer vision and robotics and industrial investor. I'm looking much more closely at what could happen with this new sphere. And then along the lines of when we were talking before on being more transparent, and if we're thinking about, for example, taxing the grid, this is something that is, if you're looking at electric vehicles, right, and then you're looking at electric vehicles and how much more infrastructure we'll need, and we're thinking about the grid and transparency. There's many things that you can do in terms of incentive to make sure that we aren't, that we're optimizing along that front for a lot of your different kinds of energy usage. And then this is something that we were talking about data centers before, that we can create incentives to be able to minimize our electricity usage and taxing of the grid to make sure that we're doing this in the most efficient way possible that's least environmentally impactful.
Yeah.
Just on the computer vision point, so it's a good example of the incrementality, I think, which we don't fully understand yet. So we've seen applications in like the network setting of using, again, traditional AI computer vision models where you're using that to identify assets and then assess condition, right? So like you can fly drones over transmission lines, identify the line and then identify condition of that line rather than having to use a helicopter or putting someone up a pole, right? And it's hard. It's hard to do, but it is possible to do. And we've done some work in that sort of space as well. Now, something like, what's it called, GPT-4V, so where now you've got the ability to take an image using GPT and then assess that image. So you can take like a picture and it'll show you like, okay, this is a picture of a man and a woman and they're wearing X, Y, Z and they're probably doing this. Like, and it's pretty effective. It's very good. But can you use it for like a really specific, targeted purpose? That's where it's like we don't really know yet. Like, and so it could be that evolves in something that you could use. Like that general purpose model could become the thing you use to start assessing asset condition. And maybe you combine it with other things like satellite data, for example, like some very exciting things you could do with it. But at the moment, it's hard to see whether it will be able to be applied like in that very focused way. Like we're very much kind of like on the moving train on this in terms of understanding. But if that's possible, that could have a huge impact. Because then if you can democratize that ability, like the amount of savings you could achieve, like operational savings, would be huge.
No, I also think there's By the way, we should really have coffee after this. I'd love to pick your brain on a lot of this. But I mean, even when you just think about the data that is ingested and all the, how you talk about that, right? We used to talk about, and I'm going to date myself and how old I am here with this, but like we used to talk about data warehouses, right? When it was just kind of, thank you, okay, I'm not the only old person here. And then, and now they're what, like they're data lakes, right? So even just like that mental imagery of like the amount of data is being like, we've moved from a confined little warehouse to like a lake, right, of data that's being ingested into these models. And so, I mean, I think your point is very important about like, they're actually different purposes, right? They're almost built for different purposes. Like it used to be specific set of data in a little confined warehouse for a very specific narrow purpose, and like, and now, it's this like really wide lake of data, and like, so it's just more open-ended, And so for things like discovery, so gene discovery, interesting microbe discovery, right? Where you are a little bit kind of like just seeing what's out there, right? And like, what are our maybe possible unknown unknowns in that quadrant of our Punnett square, to figure out innovations that we maybe haven't even thought of in a more directed and like narrow way. I think there's some potential there. I mean, you can use regular AI for that if you kind of have like a direction you want to explore. But I think maybe that's a form of incrementality in just like general fields of discovery, right, of different things that may potentially be interesting.
So I have to confess, I used ChatGPT recently to learn how to play down the line backhand in tennis. Actually, it's a very good tutor. So unfortunately, it feels like it's not the best use of resources. So let's come back. I said I'll come back to the responsibility piece.
So I think there's two levels of responsibility. There's the people who are involved in creating this technology, like us. We don't build LLMs. Well, actually, we are on DTMR, but we're not like big tech who are, putting huge resources and billions of pounds into training massive models. But we do build models as part of every piece of work that we do. And I think we should be doing more as a company in our ability to track and measure, and setting some example around that. Because until we track and measure things, like we're not going to be able to do anything about them. And that journey of kind of, it's a bit like the journey we've been on generally on carbon emissions, right? You track and you measure, and then you become aware, and then you start building that into your calculations, and then you start pricing it, and then you start making decisions differently as a result. So there's one layer of responsibility there. But there is this much broader question, which gets much more kind of political, philosophical around, we don't really talk about this. Like there's huge resources that we use now with technology and software and compute, and we use them constantly, like all the time, like every minute we're doing it, and we don't think about it. And so that resource intensity is now becoming significant. We heard the stats around the levels of usage. Like another one was like, I think in Ireland, like data center usage by 2030 is going to be about a third of their total usage. And these are quite local problems. That's the other thing as well. Like data centers aren't evenly spread around the world. They're very much in localities, certain countries, certain parts of certain countries. And we can talk about like green energy in terms of, okay, well maybe there's contracting with renewables happening from certain tech providers or data center providers. But the question is, like, is it additional? Like, or is that just kind of cornering the renewables that exist already, and that just means that there's more fossil fuel generation that's required elsewhere? And there's all kinds of grayness around this. But there is a societal awareness and responsibility around, like, how do we want to use these resources? And a very big question, like, is it okay just to like endlessly kind of produce fluff, basically, with models and software, and kind of, is it productive? And is that what we want to use our resources for? Because in the end, it's all just going to go into the market, and it just goes into higher energy prices, or it goes into like more carbon emissions. So it's a bigger question than me, certainly.
Well, that's why we have this philosophical question. Maybe I'll ask Kelly, what do you think about this? Like people like me trying to use it for learning how to play tennis.
Right. Well, there's the individual responsibility side, and as long as we go unchecked, like folks are going to folks are going to use it for how they want to use it. I think there is different tiers. So there's also the for example, government responsibility side to ensure that we're building fundamental infrastructure in a way that is sustainable for the long-term future of society. And maybe that plays a bit into the NATO Innovation Fund, in which our LPs are the 23 nations of within NATO. And thus, by opting into our fund, they're telling us that they want to invest and adopt the kinds of deep tech that we're investing in that really ensures an enduring future. So with that, we're looking at energy transition. Obviously, there's going to be some regulatory components to that. So it's both a push and a pull to make sure that we're looking at the future long term and from a societal responsibility side.
So much responsibility. So, I mean, I think the prudent thing to do is to assume that it's here to stay and it will grow and it will just become this new massive energy intensity stream within society. And then the implications for all resources cutting across all other industry verticals for that. So even stuff like construction, right? I mean, I think there's going to be something like $50 billion of growth in construction due to just data center construction alone. And so what do we look at? You know, it's actually interesting for us to go right after the built environment panel that was a second ago because, well, one, philosophically, I think it is fun, so different because, you know, on that panel, I think someone was saying, yeah, like we need buildings, right? We all live in buildings, we work in offices, blah, blah, blah. But then here you have this question of how much do we really need, right? Like all this, as you say, fluff, like AI fluff, right? So there's that, and then on the other hand, then you do need the buildings to then house the AI. So you know, it's again all these kind of circular things. Like we've invested in a lot of decentralized, prefabricated, and modular construction tech. You know, you can 3D print a building. You can do like a mini decentralized factory to build, you know, like chunks and then not have to transport them and things like that. So I think when you think through just like the knock-on effects, like suddenly now you have to step up even more, you know, everything else that you were already looking at in construction, in HVAC, in, you know, efficient energy and like all this stuff. But yeah, you know, you're not going to stop people from trying to learn how to play tennis. You know, you might be able to make some prudent decisions in a B2B way. But I think you have to assume that the consumer element of things is here to stay, and then just try to accommodate that with everything else.
Just one addition. So lots of problems. One of the potential ways around this would be, for example, if you are tracking and measuring and you understand impacts, is you could regulatory enforce that, say, data centers have a certain level of on-site generation, for example. That wouldn't be that difficult to do. Because in the end, and then you can guarantee additionality, and you can guarantee that, you know, you're not drawing from the broader grid mix, and you're not therefore impacting on the market, and you're not impacting on other people's usage. So, I mean, there are definitely solutions that you can try and implement. They would require regulatory sort of push, but it feels like it will get to that point where that will have to be enforced, or it would make sense for it to be enforced, rather than just leaving it to the market to try and sort out. Because there's also big inequality issues, I think, that start arising if you let this go unchecked, which will just cause problems down the line. There's tensions that will be created by this.
Great conversation. I'm going to leave about 5 minutes for audience questions. Maybe we should have ChatGPT being paid or something like that. That's probably going to limit use. I don't know. Yeah.
Good morning. Great conversation. And I just want to put in a reminder to demonstrate how multidimensional this issue is, that for at least the last decade, we thought about the transition to the cloud as actually a way to save energy, because we're moving a lot of on-prem resources into better managed, centralized places. And so in the debate around additionality, it's important to take that into account as well. But I'm curious about how you look upon the same issue that was mentioned in the built environment, the agency issue. because if we talk about responsibility, it cannot be individual actors or consumers, but there is a really complicated chain from programmers to data center real estate owners who all have to take action. And I'm curious about how you see the system and the incentives around that evolve to actually let happen what you just described, Andy.
Okay, so I think it moves into like a much bigger question around how we see carbon within the activities that we execute. And it's interesting when you look at what's happened elsewhere. Like I've been in the energy transition space for about 15 years now, and it's interesting to see how it's evolved and how people's perceptions have evolved. There's two ways I've seen that gets built in, that agency gets built in. One is that customers demand it, or supply chains demand it. And it's a soft impact because it's not like you're paying something directly, but you just won't be able to work with those customers or suppliers if you're not enforcing their expectations and you're not meeting somehow what they're expecting in terms of that carbon impact. And then there's the direct kind of tangible impact of pricing of carbon in some way. So the way I see agency is in those two buckets. So either as a creator of solutions, like if our customers are demanding that they want to know the carbon intensity of what we're doing, and if we're demanding back to OpenAI, when we're implementing one of their models with a business, that we want to know the carbon intensity of the impact, then this stuff will start flowing through the chain. But the reason why people start demanding that is either because their own customers are demanding it and they want to use it as a way of presenting what they do, or it's because they themselves are having to pay for it. So it comes back to that, I think. My personal view is carbon pricing across the board would make a lot of sense, but no one's really sort of pushed down that road, or carbon taxing. It's still very bespoke in terms of where it's being applied. And the built environment example is interesting because for most building providers, developers, real estate investment trusts, like they don't currently get charged a carbon price, but most of them have now built in an internal carbon price in what they do. And I missed a session earlier, but I've worked with a number, and most of the ones I've seen now use that in their own investment committee. They'll have that as a consideration, and increasingly they'll just value it as the same as revenues and costs. Like it's not even like a secondary issue. So it's very much coming into that decision making now. So I would expect the same will happen in tech.
Let's go to another question. Maybe Mark and then Girish.
Very quickly, this one is for Kelly and Helen. I'm curious from the venture perspective, maybe this is a little bit rogue, not on the climate impact, but from the investment perspective in Gen AI startups, it seems like this is a scenario where the key stakeholders in terms of ecosystem development and technology development are massive companies, the Metas and the Googles, or very heavily, hugely privately funded efforts like OpenAI. How do you see the exit opportunities for startups in this space?
Go for it. So I'd say the vast majority of startups in this space are not working on the foundation side, right? They're building on top of what is already created. So the startups, resource-wise, besides your few exceptions, we call it OpenAI and whatnot. So because they're able to work on top of it, they're a lot leaner, and thus we're thinking about them similar to how perhaps your traditional previous gen AI companies are.
Yeah, I would say the exit is just more about the end use and the application than it is about the fact that, I think you were saying AI is a tool, right? So like if you're making any kind of tool, you're not like, if I'm a hammer, I'm not selling myself to a hammer company, right? I'm building houses and then I'm selling a house, So it's, if you're using LLM and building, like a fintech credit scoring model for, solar loans or something like that, you're going to end up selling yourself probably to like a digital challenger bank or something along those lines.
Girish?
Hi. I'm curious if quantum computing can help us lower the energy use for AI, or would we sort of face another rebound problem or Jevons effect that we will now use quantum computing for even more complex problems and therefore drive energy usage even more?
I'm guessing That's a hard one for most people to answer. So I have a take on this, not because I know that much about quantum computing myself, but our CEO, Mark, was he was a PhD in quantum computing at Harvard. So, and I remember him telling me this story last week, actually, around, because someone asked something similar in a meeting we were in. He was basically like, look, quantum computing is at least 20 years away from having any impact on anything. And it's being touted a lot at the moment because I think it suits a lot of people to talk about this kind of magic solution, because it's suddenly going to make everything okay and everything efficient. But and I will bow to his knowledge on this, because he's pretty well plugged in. But I think his view is like, there's no point looking at that in the near future. Like it's such a long way off.
Thank you, everyone, for this wonderful panel. And I think the least we can do is to at least have awareness that these things are computationally intensive, energy intensive, and they take a lot of resources. So let's be responsible. Thank you.